Hello friends, this is Ganesh. Please watch my previous videos. Link has been provided in the description. In this video, we are going to see Spark introduction. Spark is an unified analytical engine for large-scale data processing. It could achieve high performance for both batch and streaming data using DAG scheduler, a query optimizer, and a physical execution engine. Spark performance will be 100 times faster when compared to MapReduce. Spark offers 80 high-level operators that make it easy to build parallel apps. We could create Spark applications using Scala, Python, R, and SQL shells. Spark has a stack of libraries including SQL and data frames, mlib for machine learning, GraphX for graphics, and Spark streaming. We could combine these libraries in same application also. Spark could run on Hadoop, Apache Mesos, Kubernetes in standalone mode or in cloud. It could access diverse data sources. RDTs, datasets, and data frames are major components of Spark. RDTs are resilient distributed dataset. As Spark is cluster computing framework, data is distributed. When it comes to resilient, RDTs could be recomputed at any point of time. So RDTs are resilient. RDT are fault tolerant collection of elements that can be operated on in parallel. We could create RDTs in two ways: by parallelizing an existing collection or using a dataset in an external storage system such as Hadoop HBase or any Hadoop input format. We could pause a list to parallelize function of Spark context to create an RDT as mentioned here. We could also create RDTs from text file by pausing the path of the file to the text file function of Spark context. The data set is a distributed collection of data. It provides benefits of RDT with the benefits of Spark SQL optimized execution engine. We could construct a dataset from JVM objects and then manipulate using function transformations like map, flat map, filter, etc. A dataset API is available in Scala and Java. Python does not have support for the dataset API, but due to Python's dynamic nature, many of the benefits of dataset API are already available. The case for R is also similar. A data frame is a data set organized into named columns. It is equivalent to a table in RDBMS or a data frame in R or Python with richer optimization. Data frames can be constructed from array of sources such as structured data, files, tables in Hive, external databases, or existing RDTs. Data frame API is available in Scala, Java, Python, and R. Scala and Java data frame is represented by a data set of rows. The difference between a data set and a data frame is data sets are typed but data frames are untyped. Then data sets will throw error during build time, but data frames will throw error during runtime. We used PySpark shell here to generate RDD. We are assigning a list to data variable and passing it to the parallelize function of Spark context. Then using the created RDD, we are printing the result. In the same way, we are using Spark context text file to generate RDD from a CSV file. Then we are printing the count of lines available in the RDD. Here we are generating a data frame using Spark session. Spark session.read.csv along with the path of the CSV file with header option equal to true. While executing this, we will be getting a data frame. We could use data frame function count to print the number of rows data in the data frame. In the same way, we could use .show method with number of rows to be displayed. We are getting top 5 rows of the data frame. That's all for the video. Please share the channel and subscribe channel. Thank you. Have a good day.